Alright, I had a hunch that you guys might want to see some of these again, so I'm going to kind of work through these quickly again. For those of you who missed the first day of this lesson, this is going to be super beneficial for you to check out. When we do these, you guys, the first ones seem pretty easy, and hopefully you guys pick up on them and they won't be so bad. But we look at our steps 1 through 3. Again, we have to isolate a variable and then substitute it into another equation is essentially what it boils down to for those steps. So since I already have a variable isolated here, I'm simply going to take this value 3x plus 2 and I'm going to plug it in for the value y in the second equation, because it is equal to y right here. This says y equals 3x plus 2. I'm going to plug it in for this y right here. Then I write my new equation, x plus 2 times the quantity, 3x plus 2 is equal to 11. So again, like I said, I took this value right here and I plugged it in for the y right here. Once I do that, I can just solve by distributing. So x plus 6x plus 4 is equal to 11. I combine like terms, 7x plus 4 equals 11. I subtract 4 from both sides. I have 7x equals 7. I divide both sides by 7, and I get x is equal to 1. Now again, we have to keep in mind that our answers in this section are coordinate point answers. I only have my x coordinate. So what I have to do now is take my x coordinate and I have to plug it in for this value x right here. So what I'm going to do is I'm going to put y equals 3 times 1 plus 2. Y is equal to 3 plus 2. And I simply get y is equal to 5. So my solution to this system is going to be 1, 5. So again, if you want to work B and C in your notes and then look at the answers once I'm finished, that would be very beneficial for you. I'm going to go ahead and pause the video and work them out and kind of talk through them quickly. So just kind of follow along as I go through it. Okay, so moving on here. I just kind of underlined what we wanted in red here. Once again, the y is isolated for us, so what essentially I'm going to do is take all of this and plug it in for the y in the second equation. So I do that first step here. I plug 2x minus 3 in for y. I underlined it in red. I filled it in here in red just so that you can see the only thing we're changing is this y right here. Then I distribute and I combine like terms and I get 7x minus 9 is equal to 5. I add the 9 to the other side and divide by 7 and I get x is equal to 2. Then I take this value 2 and I plug it back into my top equation up here. So here it is, 2 times 2 minus 3, and I get 4 minus 3 is 1. Again, all of this work, we want a coordinate point answer, so make sure that you don't just leave the 2 and the 1. Make sure that you finish off by putting it as a coordinate point. Letter C, very similar. We take this, the one thing I caution my students on, you guys, is, again, if there's nothing in front of the y here, and you're plugging all of this in for the other variable, don't put parentheses around it because it makes you think that you're going to have to distribute, and we really don't need to. Once we plug in 2x plus 5 for y, all we have to do is combine like terms, and we get 5x, and then it's just a two-step equation. We get x is equal to 1. Again, we plug that value back into the equation up top. Once we solve for y, we get 7, so make sure you put it in a coordinate point, and you're done. This is the part we actually have to pay attention to our steps from the previous page on right here. It says to look for a leading coefficient that is 1 or negative 1. So we look for coefficients. My coefficient on my first term here, we have 1, negative 2, 4, and 6 for my coefficients. So obviously I want that x to be the one that we isolate. That's the one that's going to be by itself. When we do that, we want to isolate that x, so I have to move this 2y to the other side. When I do that, it gives me a new function. It gives me x is equal to 2y minus 6. I can leave the other function exactly how it is and just write 4x plus 6y equals 4. The only thing that's different now is that now instead of y being all by itself, now x is all by itself. So all of this value is going to be plugged in for x because x is the one that's all by itself. So I'm going to take this value and I'm going to plug it in and I'm going to write my new equation. My new equation looks like this: 4 times the quantity 2y minus 6 plus 6y is equal to 4. I have to distribute my 4 and I get 8y minus 24 plus 6y is equal to 4. I combine my like terms. 8 and 6, I get 14y minus 24 is equal to 4. I add 24 to both sides. I get 14y. Let me scroll down here. I get 14y is equal to 28. I divide by 14. I get y is equal to 2. And then once again, we've already got y isolated in a formula up top, or excuse me, x isolated. So I'm going to take this y value and I'm going to plug it in where x is isolated. So it's going to be x equals 2 times 2 minus 6. X equals 4 minus 6. X is equal to negative 2. Most of my students are pretty good on this. We just have to make sure that we look for which one comes first. Our x coordinate goes first, so we need to make sure that we put negative 2 first, then positive 2, and there is your solution. Once again, go ahead and pause if you need to. I prefer that you pause and try B, C, and D. Letter B is actually very easy. Just solve for B and then plug it into the formula. But once I'm finished working them, I'll go ahead and talk through the examples just like I did before. Okay, so like I said, letter B really doesn't have much work for us because there's no x in the top equation. So I can actually completely solve for y in this formula and be done. Add 5 to both sides and I get negative y equals 17. We have to divide by negative 1. Y equals negative 17. Once I find that value, I plugged it into the second equation. 3x minus 5 times negative 17, we get positive 85. We have to subtract it to the other side. 3x is equal to negative 81. Divide by 3 and we get negative 27 for our x coordinate. And then again, we just plug it into our coordinate point, negative 27, comma, negative 17, and you're finished. Letter C looks more like example A. We're going to have to isolate a variable and then solve. When we do this, it doesn't matter because we have a coefficient right here. Coefficient's 1, negative 1, coefficient is 2. I simply chose to isolate the top x variable by adding y to the other side. So now here's my new equation for the top one. Now that I have a variable isolated, here's my variable that's isolated. I take y plus 3 and I plug it in for x in the other equation. So here's my red y plus 3 that's plugged in for x, and then plus 2y from the equation right here equals negative 6. Combine like terms, and then it's just a two-step problem, and we end up getting y is equal to negative 3. Once we find one of our variables, we substitute it back into our equation. Negative 3 plus 3 is equal to 0, and then our coordinate point we get 0, comma, negative 3. Last one here. Again, it should be pretty straightforward. The only one that you're going to want to isolate here is the y variable that's on top. The others would be a little more challenging to isolate. So I'm going to subtract my 3x over, and here's my new coordinate, or excuse me, my new equation. I take this equation right here and I plug it in for the y, and then I copy down my new formula right here. So it's negative 2x plus 4 times negative 3x minus 7 equals 0, and then it's simply combining like terms and isolating your variable. So the rest of this is just a multi-step problem that you guys should know how to do. So just look this over again as you finish this up and combine like terms and solve for your variable. You get x is equal to negative 2. Then once again, you're going to want to take that and plug it back in to the formula where you isolated your y variable. So negative 2 times negative 3, we get positive 6, minus 7, we get negative 1. And then our coordinate point answer is negative 2, comma, negative 1. That should be it for this lesson. I'm going to split it into two separate videos so that I can explain those story problems a little bit better. But again, use this to your advantage, pause when you need to, and look over these examples and make sure that you can work them out yourselves.